So today we're going to start looking at the quadratic function unit, and we today are specifically going to concentrate on identifying key features of quadratic functions. Then you're going to graph or just basically sketch a graph from a description of those key features. You're going to be able to identify the domain and range and set notation. And this is something new. You're going to identify the intervals where the quadratic is increasing or decreasing. All right, so I would like you to pause the video and try to complete this entire introduction on your own, and then restart the video and listen to my conversation about it. Okay, so hopefully you did what I asked. Shame on you if you didn't. All right, so Spider-Man. In Homecoming, Peter Parker needs to launch himself off the Washington Monument in order to gain enough speed to break open the window and rescue his friends who are stuck in an elevator shaft inside. The following table shows Peter's height off the ground based on the number of seconds that have passed since he jumped. And as you look at the table, the patterns that you should notice are that x is increasing by 0.5 seconds each time, and that the height is going from 555 is getting bigger, 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 bigger until it hits this 751. So when it hits 751 and then 3.5 right here, notice that all of a sudden y starts to go down again to 555. So it goes up, hits a peak at 351, and goes back down. So we see the pattern going up for y, hitting the peak and going back down. And so that is a parabolic arc. It could have been an absolute value function, but it's not. Both of those functions have a high point or low point known as the vertex. So the patterns that you notice would be as x increases by 0.5 seconds, y increases to 751 and then decreases. Okay, so the next question says, could you write a linear function to model the relationship between the amount of time and Peter's height? Why or why not? Well, the answer is no, because a linear function, if you think about it, as x increases, y will decrease, or as x increases, y will increase, but it will not decrease and increase as x increases. You don't have both of those because it's linear. As x goes in one direction, y is going to go in the same direction all the time. So that's what, go ahead and write that there. I'm not going to write all that out here, but you can write that there. And then, what do you think the point right here, 3.5, or I'm sorry, this point right here, 0, 555 means? So graphically, that means that at time 0, our starting time, Peter Parker is at a height of 555. So on the graph, at any time you have an ordered pair where 0 is one of the values, you either have an x or a y-intercept. And because you have a y value, it's the y-intercept. So 0, 555 represents the y-intercept. That's really terrible handwriting. You should see I'm having to write today. So it represents the y-intercept. I'll try to get better. Where, and then this is in the context, where Peter Parker, I'm just going to say Peter, is at 555 feet at 0 seconds. Okay, so then you are to sketch a graph to model Peter's time. So let's look at your table of values. So you've got it in front of you. So we've got to determine what's going to go on the x-axis and what's going to go on the y-axis. 100% of the time, anytime you have time, time is an independent variable that cannot change. So this is always our independent variable. 100% of the time, time goes on that axis. So because our time goes from 0 to 7, I am going to start here at 0, and I'm going to label every other hash mark. So I'm going to go by ones, essentially. So that's 2, 4, 6, 8, and 10. And then this is time in seconds. And then we're going to go from here to here. Now our lowest value is 555 and our highest value is 751. But you need to start here at 0. You can't go from here at 0 and make the first hash mark 555 and then go in different increments from there. You know, like go by tens. You can't do that because from 0 to here is 555 and from here to here is 10. Each hash mark has to be identical. So we're going to go from 0 to a little bit over 751, so let's say 800. So we're going to go from 0 to 800. So how does, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just go by hundreds. So again, I will label every other one. So this is going to be 200. And this will be 400. And then 600. And then 800. And of course, this is going to be our height. And that's in feet. I'm going to shorten the title of this to just Homecoming. Peter Parker's Homecoming. Okay. So let's plot our points. So notice here that it says you do not need to graph every point. So I think I'm going to plot the integer values of x. I'm not going to plot the 0.5s. And I am going to start at 0, 555, and go up to 7, 555. So 0, 555 is right about here. And then 1, 650. Would be like here. And then 2, 715 would be like here. And then 3, 747. And then 4, 747. So we really should plot 3.5 because that's our vertex. So 3.5, so maybe I need to adjust these a smidgy. Since 3.5 should be at 751. So 3.5 is at 751. So that's like right about there. So then my other points, 2, 715 is going to be right about there. And then 3, 747 is going to be a smidge under. Okay, then 4 is going to be like right about there. And then 5 is going to be here, and then 6 is going to be here. So we should be seeing mirror images at this point. And then 7 is right about there. Okay, so then if I connected those, it would look like that. And if I continued on in that pattern, it might be something similar to that. I went a smidgy out to the right further than I should have. All right, so the reason why I kept going is because the next question says, using your graph, could you estimate when Spider-Man would hypothetically land on the ground? So hypothetically is going to land on the ground here, which is at 10. So that's why I think it would be 10 seconds, according to my graph. And you should be, if you graph correctly, somewhere close enough. So I just rounded to the nearest integer. All right, so flip your page. So then on this page, we're going to look at the key features of our quadratics. And so quadratics are the function family that includes all transformations of the parent function y or f of x equals x squared. And then the graph of a quadratic function tends to look like this. Looks like a U opening up or a U opening down. And then the points where the parabola meets the x-axis those would be your roots, zeros, and solutions. So you should highlight that. Those and x-intercepts, they all mean the same thing. So if I mention a solution, you should know it's an x-intercept. Or a root, you should know it's an x-intercept. Or 0, you should know that that's an x-intercept. And you should know that x-intercepts can be called all of those. All right, then when we talk about the rest of these, let's talk about the vertex first. So the vertex is the maximum or minimum value of a quadratic function. And your vertex, and let's go all the way back to what we have been using with all of our parent functions, no matter what the parent function is. So this really is y equals a times, and then our parent function is squared, so x minus h squared, and then plus a k out here, right? So that means our vertex right here, isn't our vertex hk? So hk. And then you can get two things from your vertex. The x value of the vertex is going to give you your axis of symmetry, and the y value of your vertex is going to give you your maximum or minimum value. So your axis of symmetry is the vertical line that divides that parabola into two mirror images. So it's going to look like this. And it goes right through the vertex. So that green point is the vertex. And remember the equation of a vertical lines go through the x-axis. So it is going to be x equals, and because we go through the x value of the vertex is h. So it's x equals h. Then, as I look at these two different types of parabolas, this parabola, the vertex is at the bottom, so that is considered a minimum value. So that is the lowest function or y value. And then this is going to represent, k is going to represent that minimum value. And so if you look at this one, because it's a minimum, it's going to be y equals k. All right, then this parabola over here is a maximum because that vertex is at the top. So that's going to be y equals k also, but it's your maximum because it's at the top. So it must be the highest function value. And again, it's still k. So using that information, I would like you to complete 1A on your own. So pause the video. And I want you to identify each of these in general and then also specifically related to that graph. So go ahead and pause the video. All right, so hopefully you completed this, but you are to label each feature on the graph using the vocabulary from above. So this first thing right here, remember, is your axis of symmetry. So So I'm just going to abbreviate it, axis of symmetry. And normally the axis of symmetry would be, in general, is going to be x equals h. So on this one, because number 2 asks for the axis of symmetry, on this specific parabola, it goes through the x-axis at 1. And if you think about it, this one right here is your vertex. So let's get that vertex first. So this is our vertex. And remember, your vertex is HK. So our vertex on this one, number 3 didn't ask for it, but it'd be handy. Our vertex on this one is 1 and then -4. So our axis of symmetry, we get the x value, the x value of the vertex gives us our axis of symmetry. Because it's the x value, it's x equals 1. So that's our axis of symmetry. And then look at the graph. Is this vertex a maximum or a minimum? Since it's at the bottom, it is a minimum. So you're going to circle minimum. And then this y value gives you that minimum. And so then the minimum equals -4. Then the other items that are left on here, so let's look at this right here is crossing the y-axis, so that is our y-intercept. And your y-intercept is always going to be 0, y, whatever that y value is. And then the ones that we have not talked about would be these two items here, which are our x-intercepts. They can also be called our roots. They can be called our zeros and our solutions. And because there are generally 2 of them, you would have an x value, 0, and another x value, 0. Now the only time you're ever going to have one x-intercept is if the vertex is physically sitting on the x-axis and that parabola opens up or down. Okay, so then let's go and look at example 1b and 1c, and I want you to pause the video and I want you to fill out all of this based upon what we just talked about. So go ahead and use your notes as a little cheat sheet if you need to, but I always like to start with the vertex because then the vertex gives you the max or min and then the AOS. Please circle max or min and give its value. So go ahead and pause the video and then restart. Okay, so for this first parabola, the vertex is right here at -4, +2. So the things that we get from that, the x value of the vertex gives us the axis of symmetry, and so it's x equals -4. And yes, you have to have x equals -4. And then the 2 gives us our max or min value. And because this parabola opens down, that vertex is at the top, so that is our maximum, and it has a value of 2. Then our x-intercepts are these points right here, and so make sure you write their ordered pairs correctly. The first one is at -6, so the x value is -6, the y value is 0. And the second one is at -2, so the x value is -2, y value is 6. And finally, our y-intercept is down here. Because it's a y-intercept, it has a y value. So the y value is -6. The x value is your 0. Then for this one, the vertex is here at 2, 5. Okay, so the x value gives us our axis of symmetry, x equals 2. And then the y value gives us our max or min. And in this case, because the vertex is at the bottom, it is a minimum, and its minimum value is equal to 5. Then this parabola does not cross the x-axis, so the x-intercepts are none. I'm just going to continue that down to there. And then our y-intercept is right here at 0, 9. So hopefully that was a good review. So then turn your page and we're going to sketch a parabola. So on this page you are given some characteristics of your parabola, if you will. So the first thing you're given is your axis of symmetry is x equals -1. So let's go ahead and plot that in here. So that is your axis of symmetry. Everything should be symmetrical to that. Then one of your x-intercepts is 5, 0. So I'm going to plot that right there. So if you know one of your x-intercepts, you can find your other one. Notice that from the axis of symmetry, this x-intercept is 1, 2, 3, 4, 5, 6 units away. So we want to go 6 units on the other side of the axis of symmetry. 1, 2, 3, 4, 5, 6. Doesn't that put us at -7? Count again, you'll see I'm right. So there we go. So the other one is at -7, 0, because in order to sketch this, I need some symmetry. Then we are told that your maximum value is at 4. Maximum value implies that your parabola is going to open down because your vertex is going to be here at the top. And since the maximum value is 4, and we have to be somewhere on this line of symmetry, that puts us at right here. So that means the vertex must be at -1, +4. And you should have known that because your axis of symmetry is -1, so that's your x value of the vertex. Then from here, we can go ahead and connect. And that's close enough. Okay, let's review some definition about domain and range. So, domain. I don't know what that blank is really supposed to say, to be honest. So, the domain of a function is a set of all possible x values where the function is defined. And then normally, to identify your domain, you have to read it. So let's highlight this. We have to read it from left to right. So, and we'll go over that again. So then your range, the range of a function, is a set of all possible, and again, I think this should be y values, because that is what it is. And then to identify the domain, oh, interesting. So they have a mistake. This should not be domain, it should be range. And I didn't notice that in class today. So we go from bottom to top because look at these. So if I'm going to look at the domain, remember we always walk the x-axis from left to right, left to right. But if we're going to do domain, we always go bottom. Whoops, it's going to be hard for me on this graph. I'll have to move it up. But we always go from the bottom, low end, to the top because that's the direction of the y-axis. Then finally, you're going to use interval notation. And again, we've talked about this to identify your domain and range. It's called an interval notation or set notation. So remember, if we were using a number line, x is greater than or equal to 3, you start at 3 and go to positive infinity. So start at 3. Since it's equals to, we close it with a bracket and go to positive infinity. So we use parentheses for boundaries that are not included. That's like an open circle on the number line. And we also use it for our infinities because we don't really know what number those infinities are. And then we use brackets for boundaries that are included, like this one here. It's like a closed circle on the number line. So let's review domain and range with these 3 parabolas. And while we're doing that, I want you to make a claim about the domain and range of any quadratic. So let's start off with walking the x-axis from the left side to the right side. So from the left side, doesn't this graph, it does go up infinitely, which is a y direction, so that's not what I'm interested in, but it does go to the left infinitely as well. So because this graph eventually is going to keep going left, 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 left forever, our leftmost x value is negative infinity. And then the graph goes down and it goes back up, 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 up forever. As x goes to the right, this graph is going up and to the right forever. So again, right is an x direction. And so your domain goes from negative infinity to positive infinity. And if you think about it, the parent function is this. This is saying all real numbers. It is saying that the domain is not restricted for a quadratic, which is true, because I can put any number I want to in for x, positive, negative, 0, fractions, decimals, and square it, and I can get an answer. So there's no number I can't think of that I can't square. So now let's find our range. Our range goes from low to high. So our lowest range, there's no graph underneath here. The lowest value we get on this graph is right here. And the y value for that point is -3. So our range starts at -3 and it includes -3. So we're going to put brackets because that ordered pair right there has a y value of -3. And then we go from -3 up forever to positive infinity. So our range goes from -3 to positive infinity. So then I want you to pause the video and I want you to see if you can find the domain and range for these two graphs. So if you paused your video for 3b, if we go from left to right, again, this graph is going up and to the left forever, up and to the right forever. Left and right forever are x directions, and left is negative infinity, right is positive infinity. So again, the domain here is negative infinity to positive infinity. And while I'm at it, let's talk about 3c for the domain. Again, this time though, we're going down and to the left forever, down and to the right forever. So we're still going left forever, we're still going right forever, which again, you'll notice that the domain is the same for all three of these. So the claim that we can make about the domain is that it is always negative infinity to positive infinity. Then we're going to look at the range for both of these. So the range here, we're going to go from low to high. So our lowest range value is here at the vertex, and it is a y value of 5. So we're going from 5 to positive infinity. And 5 is included. We have an ordered pair with 5 as a y value and to positive infinity. And so then on this one, this graph is reflected. So notice that our lowest value, it keeps going down infinitely. The infinity for down is going to be negative infinity. So we're going to go from negative infinity all the way up until we reach this maximum value here, which is a y value of 2. So for a range, we're going to go from negative infinity to our maximum value for y, which is 2. So a claim that you can make about the range is it always involves the vertex, really specifically the maximum or the minimum value, because those are the y values. So it is for the minimums. Notice that the minimums started at the minimum value and both went to infinity. So for the minimums, you would have minimum, then comma infinity, or if it's a maximum, like this one, you're going to go from negative infinity to the max. So negative infinity to the max, and brackets. All right, so then let's turn our page and look at the very last page. So in this last page, we're going to discover something new. We're going to talk about increasing and decreasing intervals on graphs. So we like to start with quadratics because it tends to be the easiest graph. In the vocabulary for this one, we're going to look at graphs that aren't quadratics here for a moment so you can kind of see what we mean by this. So increase in a function or part of a function, because we're really only looking at a part here, is said to be increasing if the y value, so notice that as x is getting bigger, you go from left to right, x is getting bigger. Notice here how y is increasing. So the y value increases as the x value increases. So the funny thing about increasing and decreasing intervals is your brain is going to war with x and y, because we are going to make our intervals out of how we partition the x-axis, but you're going to look at what the y value is doing. As we move from left to right on the x-axis, what is y doing? Is it going up or is it going down? So I like to look at this as if it's a roller coaster. As we're going from left to right, ride the roller coaster. Isn't y going up? Sure is. So this is an increasing function. This one I need you to fix this part. It should say decreasing. So that's decreasing. All right, so a function or part of a function is said to be decreasing if the y value decreases, because it's all about the y value, decreases as the x value increases. Well, what does that mean? Okay, so again, notice that our x value, we're going from left to right. So notice our x value is increasing as we go from left to right, but notice this time what the y value is doing, it's going down. So the y value is decreasing. All right, let's try this out. Let's look at for A, B, C, and D. So let's start with A. So with A, you always want to split your interval where the graph has a turning point. And so the graph is going to have a turning point anywhere that there's a max or a min. So right here is a vertex. So I'm going to put a dot right there. That's our turning point. And so what's going to happen is we are going to cut the x-axis right here at that turning point. And the x value at that turning point is 0. That's the x value at that turning point. Then to the left here, the smallest x value to the left, because we only have one cut on the x-axis. So the smallest x value way over here is negative infinity. And then the largest x value way over here is positive infinity. So our x-axis has been cut into two intervals, negative infinity to 0, and then 0 to infinity. So once you make those cuts, you have to look to see what is y doing. So on this interval from negative infinity to 0, what is y doing? As you move from the left to the right, ride that roller coaster. From the left to the right, we're going to start up. Isn't y going down? As we move from left to right, y is moving down. The bigger x gets, y is moving down. So y is going in that direction, and it's going down. Since y is going down, that's a decreasing interval. So the interval is decreasing from an x value of negative infinity to 0. Parentheses. Now we don't put brackets here because at that turning point the graph is neither increasing nor decreasing. So at 0 we don't include it. So that's why there's parentheses. Then this interval, notice that as we go from left to right, the y is going up. So for some of you, you're like, what? Okay, it's a spatial reasoning skill. You have to move from left to right always, but look at what y is doing. So as I move from left to right, y is going up, ride that roller coaster. So that means that our increasing interval must be from 0 to infinity. And once again, I'm using parentheses at 0 because at 0, an x value of 0, the graph is neither increasing nor decreasing. So then let's look at example 4b and see what happens when the graph is reflected down. So again, I want to look at that turning point right here, which is the vertex. So at that vertex, we're going to cut the x-axis right here. So we're cutting the graph right here. So right there where I cut it, isn't the x value here at 2? That's the x value. I don't care about the y value right now. I don't care about the actual y value at all. So that's where we cut it, and then the leftmost x value all the way over here is negative infinity. The rightmost x value over here is positive infinity. So those are two intervals, from negative infinity to 2 and from 2 to infinity. We need to figure out which one is y increasing and which one is y decreasing. So as I move from negative infinity to 2, ride that roller coaster. We start down here at negative infinity, and y is increasing until we hit 2. At negative infinity, y is increasing until we hit 2. So we are going in this direction, which is up. If that's up, that must be increasing. So our increasing interval this time goes from negative infinity to positive 2. Again, we put parentheses at 2 because at 2, the graph is neither increasing nor decreasing. Then continue to go from left to right. As we go from 2 to positive infinity, notice what y is doing. It is going down. Y is going down. Ride that roller coaster. So because y is going down, it is decreasing from 2 to infinity. Now you try. Pause the video, and I want you to figure out 4C and 4D. Okay, so hopefully you actually paused the video. Here is the vertex right here, and if I cut the x-axis right here, whoops, my x value is going to be -2. My smallest x value is negative infinity. My largest x value is positive infinity. So my two intervals should be negative infinity to -2 and -2 to infinity. So as I go from negative infinity to -2, ride that roller coaster, y is going down. So we're going down. So that's decreasing, so I'm decreasing from negative infinity to -2, and we're always using parentheses on increasing, decreasing intervals. So then as we go from -2 to infinity, ride that roller coaster. Now y is going up. Okay, so that's increasing from -2 to positive infinity. And then finally, 4D. Our vertex is right here. Well, that one's kind of hard to see, but if you look really carefully, if that's 1 and there's 1, 2, 3, 4, then as we cut this right here at that vertex, the x value of that vertex is 1/4, right? 1/4, and then we have our smallest x and our largest x. So our smallest x is negative infinity to the 1/4, and then 1/4 to positive infinity. So let's look at these intervals. From negative infinity to 1/4, isn't our y going up? So our y is going up. If our y is going up, we are increasing from negative infinity to 1/4. And as we go from 1/4 to infinity, ride the roller coaster, y is going down. And because y is going down, we are decreasing from 1/4 to positive infinity. So when you do your homework, I want to remind you that the directions tell you to identify the different elements of each of the graphs, but I have included in Google Classroom that you are to also include the domain and range and the increasing and decreasing intervals. So make sure you include those so you don't get half credit. All right, good luck. It should be a nice, easy homework.